Hello, my name is Massima Mansouri. I'm an assistant professor in the School of Computer Science at the University of Birmingham, UK. Today, I'm going to focus on this question: can current method in knowledge representation and reasoning make robots culturally robust? Let me start with explaining why I'm asking this question. The field of human-robot interaction has long focused on introducing social and cultural thinking into robotics. The main motivation behind this is to enhance a robot's likability, trustworthiness, and perhaps the comfort of its users. There are a handful of studies suggesting people prefer robots that comply with the social norms of their own culture. Therefore, researchers have widely studied how to program culture into robots. Let me show a video of an effort produced by the CRASES project. CRASES was a 3-year international multidisciplinary project whose goal is to design the first robot that can assist older people and adapt to the culture of the individual that they are taking care of.
At around 2020, robots were already very capable. Some were strong, some were clever, and some were extremely precise. But as powerful as they were, robots were sometimes awkward and didn't really know how to behave with humans in many situations, even the simplest. That all changed when a group of European and Japanese researchers developed KR&R, a revolutionary artificial intelligence. When it was wired into robots, KR&R added a key feature. The robots learned to adapt to the culture and habits of the people they interacted with, and they never used stereotypes. The technical word for this is cultural competence. So it became easier for robots to be accepted by humans. With cultural competence, KR&R started a new era in the history of robotics. Soon, robots began to support caregivers, assisting older people in a variety of tasks all over the world. This development was valuable to health systems in many countries and helped them better deal with the needs and preferences of an aging population.
Fantastic. But there is one subtle point here. The researchers of this project, and in fact, many other robotic projects working on culturally enhanced robots, make an implicit assumption. That is, the current AI method can represent culture, and following this assumption, they only focus on how culture should be represented. My paper questioned these assumptions, hence the title of my paper. For investigating whether we can program culture into robots, we should first discuss what we mean by culture and what formal artificial intelligence method exists for this purpose. In the classical sense of AI, a formal model of how the robot world looks and works is expressed in so-called knowledge representation and reasoning formalism. Let's see how knowledge representation and reasoning have been used in the current cultural-aware robotic research. The design of current method often suffers from a simplicity driven by what I call a computational reductionism. This computational reductionism usually manifests itself in one of the two forms: reduction of culture to a single variable, reduction of culture to a modeling of preferences. There are plenty of examples of those in the paper, but let me illustrate briefly what I mean by these two forms. In the reduction of culture to a single variable, experiments use culture as an experimental variable which is decontextualized from any social context. Often, a person as the only subject of the experiment is reduced to a variable accounting for nationality, and the possible behaviors are among those culturally normative ones programmed by roboticists. For example, in the video I showed you earlier, despite the claim that culturally competent robots never use a stereotype, robot is programmed to stay as far as a human based on the nationality of the human subject, which means that the robot should stay further away from the British woman, which by the way depicted as a white person, rather than the Japanese man during the conversation. Another computational reductionism is a reduction of culture to the modeling of preferences. For those of your audience coming from the background other than AI or robotics, I have to say that in these fields, researchers widely study how to represent preferences as a quantifiable degree with different knowledge representation and reasoning formalism. These problems are often computationally difficult to solve, but solvable in practice due to the use of domain-specific knowledge. In these approaches, cultural factors often parameterize into robot atomic behavior, such as interpersonal distance and the directional approach, in order to match the preference of its user, hence again, decontextualized from a wider social context. Let's look at what is culture. There are countless definitions of culture. My reference to culture is what Fisher described in his book of Culture and Cultural Analysis as experimental system. He says, culture is not a variable. Culture is relational, it is elsewhere or in the passage. It is where meaning is woven and renewed, often through gaps and silence, and forces beyond the conscious control of individuals, and yet serves as a space where the individual and institutional social responsibility and ethical struggle take place. This definition of culture suggests that culture is not a set of patterns to be copied, but is in the continuous development, deprecation, revival, and as Selma Sobanovic and her colleagues stated, involves question of ethical and social choices between multiple alternative futures. Now, when we are talking about culturally robust robot, we mean robots enhanced by knowledge representation and reasoning method, which somehow sufficiently express this interpretation of culture. Then the question is, which knowledge representation and reasoning? This is in fact a difficult question. The Handbook of Knowledge Representation has 1,035 pages, and yet we are only talking about KR&R methods, not machine learning AI methods. Machine learning is vastly used in social robotics, and the issue around biased dataset has been in the spotlight recently. In this paper, I only analyze representations suitable for encoding and expressing information as propositions, thus intentionally avoid discussion around the well-known machine learning data bias issues. Also, among the massive pool of KR&R methods, there is a small set used in the context of the culturally aware robotic. For instance, if I were to talk about KR&R for ethical specification rather than cultural aspects, the task of selection of methods for evaluation becomes almost infeasible. My methodology was to do a qualitative study over a handbook of robotics and analyze the chapter of AI reasoning method. As a result, I only focus on two specific KR&R methods, namely description logics and Bayesian network. My claim is that these methods are somewhat representative of logic and probability-based approaches that are most prevalent in any other KR&R method applied in cultural robotics. Now we know that which KR&R methods we want to inspect, let's get back to our original question. Can current method in knowledge representation and reasoning make robots culturally robust? In knowledge representation and generally in logics, the question of whether a method is appropriate for a specific purpose is often discussed under two criteria: epistemological adequacy and computational adequacy. According to John McCarthy, known as the father of artificial intelligence, epistemological adequacy in AI refers to what kind of facts about the world are available to an observer with given opportunities to observe, how these facts can be represented in the memory of a computer, and what rules permit legitimate conclusion to be drawn from these facts. From a philosophical point of view, Epistemology focuses on what is potentially knowable with maximal opportunity to observe, whereas AI must take into account what is knowable with available observational and computational power. Now, let's start to analyze epistemological and computational adequacy of description logic and Bayesian networks. Before this analysis, I will briefly explain description logic, or DL. DLs form a certain family of subsets of first-order predicate logic, which allows certain restriction on expressiveness, thus enabling more problems to solve efficiently. Basically, by formally getting rid of some expressiveness, you gain more computational power. In description logic, we represent knowledge in two parts. First, operantology, which describes general domain concepts as well as relation between these concepts. This is called T-box, or terminological knowledge. You see an example of a T-box describing robot tasks with respect to the general culture generic knowledge in the slide. I took this ontology from the paper specifically proposing a knowledge representation framework for culturally competent personal robot. In this T-box ontology, boxes depict concepts like goals or norms, or a solid line denoting a hierarchical relation exists in ontology, like grid waves up, which is a grid operator referring to a type of greeting the robot has in its own knowledge base, like waving. A second part of domain representation using description logic is A-box, or assertional knowledge. A-box describing specific instances of what is expressed in the T-box. For example, this ontology is a culture-specific A-box of British culture at national level related to robot goals, actions, and cultural parameters. Now that we know about basics of description logic, let's get into their inadequacies regarding the representation of culture. DLs offer different reasoning methods. The most common one is a subsumption inference, which checks whether there is no contradiction among the definition in the A-box or T-box, and ensures that the classification of concepts from the general to the specific is consistent. The inherent hierarchical nature of DL practically disallows representing non-hierarchical concepts. For example, a subsumption relation indicating that an individual behavior is subsumed under a superconcept, such as cultural norm, ignores the fact that normative human relations with technology are constantly changing. This is still under the assumption of norms being a valid way of defining culture, which is, of course, debatable. Another problem with ontological representation of culture in DL is the inability of DL in dealing with non-monotonic reasoning. A logic is non-monotonic if some conclusions can be invalidated by adding more knowledge. In a system with culturally robust robots, culture is repeatedly assembled. Meanings are deconstructed, renewed, and dynamically adapted through time to fit contemporary circumstances. DL, however, doesn't allow retraction of knowledge in the light of further information, hence is not adequate for expressing cultural robustness. In addition to these formal properties, other aspects of description logic, which are inherited from the general class of predicated-based logic, hinders implementation of culturally robust robots. One aspect related to discretization of the culture. Contemporary social scientists believe that the construction of culture takes place in a situated and dynamic way, so meanings are often vague, contested, or even contradictory. Therefore, it's hard to reduce this very imprecise definition to discrete variables to be programmable into machines. Also, to make reasoning computationally efficient, meanings, variables, and their relation must be represented as minimally as possible, This is why cultural models such as Hofstede's 5-dimension model attract roboticists, because this model discretizes the culture for them. So of course, and this is under the unrealistic assumption of cultural homogeneity of a nation. The other issue is the implicit power relation. It is the researcher who specifies social hierarchy in the DL, define what is dominant and what is subcultural, or who has the authority to construct the cultural meaning of robots in the interaction with users. In this language, the inherent implicit power dynamic between the designer and the user is not reflected anywhere. I want to emphasize that the issue with the specification, in this case cultural specification, does not lie within the moral capacity of the designer, which arguably can be eliminated through ethical training. The issue is the lost representation of implicit power relation. One might say, instead of let roboticists specify what culture is, let's use evidence. Put humans in experiments and gather information instead of dictating cultural normative behavior to the robots. This is actually somewhat the idea behind using probabilistic language such as Bayesian networks for dealing with lack of knowledge about cultural aspects of a robot's domain. Invariance in Bayesian probability theory in general is to infer the probability of some event of interest given other relevant probabilities known as prior. This is basically identifying hidden causes from observed effects. In Bayesian probability, the conception of truth is the same as the classical logics. Objectively, a fact is supposed to be either true or false. Probability just models the subjective evidence that is true. Therefore, the issue with the discretization of the culture, as I described before, in the case of DL, holds here as well. Another issue concerns prior liability. The current practice is to identify a set of variables following a probability distribution to indicate a designer's current belief about what culture means and how its salient attributes are defined. Then evidence can modify the beliefs. The important question here is how the selection of variable sets and the initial values standing in for the user cultures affect the beliefs. Theoretically speaking, the impact of this prior diminishes as amount of evidence increase. This implies that our experiments require a substantial amount of evidence, people in this case, to possibly counter-bias the prior. This requirement is almost impossible to meet in practice. Also, inference in Bayesian probability theory can be used in practice only if evidence is assumed to be independent. Bayesian networks address this important limitation by breaking down full dependencies to a set of very small local ones, therefore reducing the representational and inferential effort drastically. The fact that these evidences have to be independent to be computationally adequate makes the Bayesian network epistemological inadequate. Why? Bayesian networks are enabled to model cultural theories involving many interrelated factors, such as an intersectional view to culture, where gender, sexuality, religion, race, or other defining aspects of identity are interrelated. Okay, let's wrap up. What I argued so far was that the two representative KR&R methods are not epistemologically adequate for culturally robust robotic systems. I do not claim that these are the only KR&R methods one could use. In fact, many researchers combine different knowledge representation and reasoning formalism to be able to express the many aspects of the problem, as each individual formalism can often deal with some aspect, not the others. Whether a system composed of formalism, each of which alone is epistemologically inadequate for cultural robustness, can constitute an overall culturally robot system is a topic for future discussion. Nevertheless, I believe that my paper has enabled such discussion by providing a set of criteria with which the notion of culture for KR&R can or cannot be defined. This includes discrete variable adequacy for representing fluid concept, power and its presence in the structure of representation, non-monotonic reasoning as a requirement for deconstruction of meanings, and the implication of imposing assumption on problem structure for epistemological adequacy. Also, I advocate that background theory aiming at capturing ethics and social choices for including culture in a robot model should be audited against the fluid, intersectional, and dynamic definition of culture. And finally, I suggest that robot personalization should not be confused with culturally enhanced robot. Personalization is the action of designing or producing something to meet individual requirements. We should develop KR&R models that represent explicitly individual preferences rather than aiming to characterize common attributes of an arbitrary groups, label them as a cultural norms, and program this simplified interpretation of culture in a robot. Thank you very much for your attention.